Section 3 of Chapter 6 is function operations and composition, and you know that operations are adding, subtracting, multiplying, and dividing. So we're going to add, subtract, multiply, and divide functions. Now, you've done this before, but of course, I can't leave well enough alone. We got to make things more difficult. So what we're going to do is you've done all these operations to linear functions and to cubic functions and to quadratic functions. So having no exponents and having 2s and 3s and 4s. So now what we're going to do is we're going to give you a power function, which simply means that your power is a fraction. So you can do this. This is so easy. It's the same thing that we've done, except now we're going to throw in some fractions. So it's going to look different than things we've done, but I promise you it's exactly the same thing. So what we're doing here is I'm giving you the function of x, the function f of x is 5x to the 1/3, and the function g of x is negative 11x to the 1/3. What I want you to do is, first I want you to add the function of x, or f, and the function of g, and then I want you to subtract them. So I've given you 3 different problems here. So what we're going to do is we've given you the same function, holding on to those functions. We want, for a, we want to add the function of f and the function of g together. So you simply plug those things in. So for a, you're going to take the function of f of x is 5x to the 1/3. And the function g of x is negative 11, so plus a negative 11x to the 1/3. And in this case, x to the 1/3 are not like fractions, they're like exponents. So these are like terms, so we can just combine them. So 5 minus 11 is negative 6, so negative 6x to the 1/3. Ta-da, done, that's it. I promise that's all there is. So with this one, for b, you want to take the function f of x and subtract g of x. So you take 5x to the 1/3, and now you're going to subtract a negative, so you're going to add a positive 11x to the 1/3. And once again, you've got like terms, so you can simply add. So 16x to the 1/3 is your final answer for b. Now for c, also what I'm going to want to do in here, when we worked with just regular linear and quadratic functions, we just understood that it was just all real numbers was the domain. Those are the numbers that you can use in these types of functions. It's different when you have a fraction as your exponent, because that means you've got a root involved. And so the domain, so we're going to ask you about the domain in each one of these. The domain is what number can I put in? Well, in this case, and the domain of a function is what numbers can I put in and get real numbers out. All right. So the domain of a combination, if you're adding functions or if you're subtracting functions, the domain of that combination is going to be the domain of each of them together. So we can look to see the domain of 5x to the 1/3 is just any number, because if you've got an odd number in your denominator, that means that your root is odd. So you can have either positive numbers or negative numbers under that root symbol. So if you had if you had a negative 8 cube root, well, negative 2 times negative 2 times negative 2 gives you negative 8. So you could have negative 2 be one of your answers. So anything you put in for x will work. It's not the same if you had a square root. If you had a negative square root of 16, that's where your imaginary numbers come in, because you can't take anything times itself and get a negative. So with both of these, x to the 1/3 power, the domain of this function is all real numbers. The domain of this function, because you also have an odd denominator of your exponent, is all real numbers. So if you're going to add them together, your answer is that the domain of this is all real. All real numbers will work in here. And the same if you subtract, because these are all real and this one is all real. So your answer, your domain of the difference between the function is also all real numbers. We'll do more and more of these, and then hopefully it'll click when it is and when it isn't. So if your fraction has an odd number in the denominator, then all real numbers are your domain. Anything will work because it can be positive or negative. All right, now let's do some multiplying and dividing of functions. I'm going to change your functions. We've got f of x is 8x and g of x is 2x to the 5/6 power. So if you're going to multiply these functions, you just multiply the functions. So the function of f of x is 8x, so you just put that down, 8x, oh, and I'm standing in front of it, times g of x. So you're going to say times, well, that g of x is 2x to the 5/6 power. So you're simply going to multiply. And remember, when you're multiplying, you don't have to have like terms. You just multiply straight across. So your 2 times 8 is 16, and your x times x to the 5/6. Remember, when you're multiplying, you're going to add the exponents. And this one, since you can't see it, is a 1. So this is 6/6 plus 5/6 is going to be x to the 11/6. And we're just going to leave that as it is because we don't want mixed numbers in there. That just makes things all messy. So we're going to leave that 16x to the 11/6. And that is your final answer when you multiply those two functions. All right, so let's divide them. For b, we're going to divide them. So you're going to put the 8x is your function of f, and your function g of x is 2x to the 5/6. So this is exactly, now it's a problem exactly like what you've done in previous sections. You're simply going to reduce this. The 2, and this is 2 times 4, so the 2's reduce and leaves you 4 on top. And then you're going to, this is 5/6 on bottom and 1 on top. So what I would do in this case is bring this up, and this is a 1 already, and this is 5/6 in the bottom, so it's going to be 1 minus 5/6. So brought that back up, and so now this is x to the 1/6 power. So 4x to the 1/6 power is your final answer for letter B here. So letter C says, okay, what are the domains of each of those? So you look separately at each one. 8x, the function or the value of that all real all reals will work for f. And remember, if you've got an even number in your denominator of your exponent, this needs to be all, let's see, how do we say that? Because zero can be an answer, but it can't be, non-negative. It's called all non-negative. So that still includes 0 in our domain. So we can have anything that's a non-negative. So 0 and up will work for our x here. So we've got all real numbers, all non-negative real numbers. So when we combine them, our domain for this combination here, when we multiplied them, so now we've got all real numbers and all non-negative numbers, but all non-negative numbers is not all of them. So we have to go with the smallest common denominator, okay? So all non-negative numbers has to be our domain because all real numbers won't work now. So all non-negative numbers is our domain for 16x to the 11/6 power. All right, so now when we divide, our answer is, what happened? Do we not have any? Did I do it right? Yes, I did. Okay. So now what happens here though is if you look, so we've got all real numbers and all non-negative numbers, but if we have a denominator, remember we cannot have a denominator that is 0. So now all of a sudden, this one is not just all non-negative numbers. 0 can't be included. So the domain of this one now is all positive numbers. Does that make sense? So the difference between non-negative numbers and positive numbers is 0 is not included in this one. Because if 0 were here, then we would end up with a fraction that's not possible. You can't divide by 0. It doesn't work. So all positive x's will work here. All positive real numbers will work in this function. So that is your domain. All right. So far, so good? Are you sticking with me? So that's the function operations. We're simply going to add, subtract, multiply, and divide, and being careful that if you've got an even denominator, you can't have negative numbers in your domain. So your domain has to be non-negative numbers. All right. The next thing is, this is getting fun. Here we go. The next thing is composition. Composition of functions is where you have a function of a function. All right, here's how it's going to work. So I've given you two functions here. F of x is 3x minus 4, and g of x is x squared minus 1. And what I want you to give me is f of g of negative 3. All right, so what you got to do is just take one step at a time and don't get all freaked out. So you're going to work from the inside out. G of negative 3 is easy. You know how to do that. You're just going to you're going to substitute negative 3 for the x in the g function. So this is going to be negative 3 squared minus 1. Well, that's easy. Negative 3 squared is 3 times 3 is 9. 9 minus 1 is 8. So now all we have is, so this g of negative 3 is equal to 8. So now we just have f of 8, which is 3 times 8 minus 4. You with me? So I took the 8 and put it into my f function now, because now I want f of 8. So 3 times 8 is 24. 24 minus 4 is 20. So f of g of negative 3 is 20. All right, let's do some. And what we're going to do is we're going to work them with the functions themselves instead of getting a final answer. So here's what we're going to do. I'm giving you the function f of x is 6 times x to the negative 2 power, and g of x is 4x plus 5. What I want you to give me is f of g of x. All right, so we're going to start out with g of x is 4x plus 5, right? So 4x plus 5. So 4x plus 5 now becomes what we want to take the function of. Okay, so this becomes our x, the whole part. So now if I want f of x, I want f of this whole thing. So this becomes my x. So I'm going to take 6 times my x, which is this whole 4x plus 5. It's the whole piece to the negative 2 power. Okay? So then to simplify that, you would simply square the 4x plus 5. And if you remember the shortcut, you're going to square the first one. 4 is 16x squared. Multiply the 2 together is 20x times 2 is 40x. And then the last term squared plus 25. And now that's to the negative 1 power times 6. So now we're going to have that whole fraction, that whole, let me look and see. You know what? Looky there. Looky there. I made it harder than it should have been. As I was working, I was like, why are we doing all this? Let's not do all of this. Let's skip all of that. And let's just say this is going to go to the denominator, so the 6 stays in the top, and the 4x plus 5 comes to the denominator, and it's still squared, and you're done. I was going to say, well, now we want to factor it. Well, why would we factor it? We just multiplied it, all right? So this is as far as you're going to go, all right? Let's do another one. Let's do g of f of x. So f of x is 6x to the negative 2, and we want g of that. So g, if you think you're getting it, pause and do it and come back and see if we get the same thing after I fix my mistakes. All right, so 4x plus 5 is going to be g, and you're going to put in the whole 6x to the negative 2 in for x. So we're going to put 4, 6, here, let me come over here, x to the negative 2 plus 5. Did you see where it came from? So this whole part, this whole puzzle piece went in for x. So that whole thing got put in here for x. So then you're just going to simplify. So 4 times 6 is 24. 24 over x squared plus 5, and you're done. All right. One more, g of x. See what you can do. Pause and come back. Did you do it? I hope so. Here we go. G of x is 4x plus 5. And so now you want g of 4x plus 5. So you're going to put the whole 4x plus 5 in for this x. Back and forth, back and forth. So now you're going to put in 4 times x, so times the 4x plus 5, because this is our x now, plus 5. Did you see where the parts came from? There's a lot, but if you can think of this as a puzzle piece and just stick it in there. So now you're just going to simplify it as far as you can simplify. 4 times 4 is 16x plus 20 plus 5. So now 16x plus 25. And that's as far as we'll go. All right? Simple, right? Oh, yeah. Okay, so the last part of this is, well, now we've got to make sure that we know what our domain is on each of these. So let's see, so on the first one, well, first of all, we look to see, we've got all, there's not any fractions in our they're not power functions. There's not any fractions in our exponents. So these are all real numbers. All real numbers are our domain. Anything will work. And so we go to our answer then and say, oh, all real numbers except where your denominator is 0. So this denominator is 0 at negative 5/4. Do you see what I did? I set this 4x plus 5 equal to 0 and solved it. So the domain of our first one is all real except negative 5/4, because at negative 5/4 this denominator becomes 0. All right, this one is all real numbers except the denominator of this fraction can't be 0, so this is just all real except 0, because you can't have 0 in your denominator. And this one doesn't have any fractions, so the domain of this one is just all real numbers. Easy sneezy. Got it? So the trickiest part is going to be translating from all of those f of x and g of x and what. Calm down and just look at it part by part by part. Turn it into an equation that you can just simplify. All right? You might be adding them, subtracting, multiplying, or dividing, or you might be using a composition, taking a function of a function. So put in the puzzle piece and then put in the next puzzle piece. So go slow on those and don't try to do all of it at once. Take it one step at a time and write it out. All right? I'll see you next time.